So the opener on you guys' desk says 411, but today's date is actually 412. So we're going to go ahead and do yesterday's opener for today, just to kind of get us caught back up after testing. So earlier in the week, we finished up the greatest common factor notes, which we did on Monday. We started it on Friday and finished it on Monday. Today, we're going to do an opener where it says, find the greatest common factor of the terms in each of the following expressions. Now, when I say terms, basically all that terms mean, it's the number and the variable. You know a term is a term because it's separated by an operation sign, addition, subtraction, multiplication, division. So if I'm looking at this right here, how many terms do I have? 2. How many terms do I have?
2.
How many terms do I have for the last one? 3. Yeah. So that's all it is. Terms is just the number and variable put together. Now, you're still going to follow the same steps that we did Monday and this past Friday to find the greatest common factor. So you're basically ignoring the operation signs, okay? So all you're going to do is ignore the operation signs, and you're going to factor each of the numbers. So it's everything that we've already done, except for now I'm starting to set it up on how, giving you problems of what it's going to look like, what we're going to factor. Okay, so we need to find the greatest common factor for the terms 6, 8b and negative, well, we're not going to even pay attention to that negative, but 8a squared. So the first thing that I start is I do a factor tree. So what are the two factors of 6? What are the two factors of 6? What two? 2 and 3. Okay? And then we're going to go over to 8. And we're going to have 2 and 4. If you haven't started writing, I would. And then what are my factors of 4?
2 and 2.
Okay. I'm going to come up to the right here. I'm going to write out 6. And I'm going to write out 8. The factors of 6 were 2 and 3. And the factors of 8 were 2 times 2 times 2. Okay. From here, I'm trying to find the common factors. What factors or numbers?
2.
A group of 2s. So good. So they share one group of 2s. So the greatest common factor for 6 and 8 is 2. But we're not done yet, because now we threw variables in here. So I go back, give me a second please, and we're going to look at our variables. Do they both have an A?
Yes.
Yes. Which A do I use?
A. Wait, no.
A, B,
I use the A with the smallest,
number.
what's that key term though? Exponent. So if you have A and A squared, which one's smaller? A. Because basically A is like saying it's A to the first. Okay, I come back up and look. Do they both share a B? So no, they don't have that in common. So it's not part of my greatest common factor. So the greatest common factor for the two terms is going to be 2A. This, being able to find this, is going to be so important for the lesson that we're going to do after spring break. I had to think about how I adjusted our schedules here.
How are you going to just drop out the B like that?
The B, because they don't have it in common. They don't share it. And remember, the C and GCFS stands for common, so they have to both have it. All right, here we go. So we come down to our next two terms. 32x squared, y to the 5th, minus 24x to the 5th, y to the 3rd. All it's asking me to do is find the greatest common factor of the term. So I'm not going to worry about the subtraction sign, that operation sign. I'm just going to find the greatest common factor. So I do that by making my factor tree. What two numbers, Daisha, can I multiply together to get 32? Keep going. Lots of 2's on that one. Okay. Kaylon, what are two numbers I can multiply together to get 24?
What? 2 and...
What's 24 divided by 2?
12.
There you go. Circle my 2. Okay, what are your factors of 12?
Oh, you want me to keep going?
Yeah, sorry.
Oh, it's 2 and I can say, what is it? 6. And then it's 3 and 2.
Okay. So we come up to the right. So how many 2's do I have for 32?
4.
Are you sure?
No, you got 2 here.
5. Okay. And then my factors for 24 are, well, I got 3 2's and 1 3.
And 1 3.
Okay. Raise your hand if you can tell me what I do next.
You're going to do.
Raise your hand if you can tell me what I need to do next. Alex.
You have to compare your numbers.
Okay, what do you mean by compare my numbers?
I mean, it's like 2 and 2 and 2 and 2.
So I'm finding what they have in common. So I have, you said a 2 and a 2, another group of 2's. Anything else? Another group of 2's. Anything else? That's it. So my greatest common factor is what?
2
Times.
X.
No. 2 times
Oh, 2.
times,
2. I thought you were doing that.
which equals,
6.
I'm going to drop down here. What?
Wait, oh, you times 2.
So 2 times 2 is 4. 4 times 2 is 8. You're taking 2 times 3. Okay, so then what you're trying to do just a second ago, you went and looked at your variables. Do they both have an x, Alex? Which is the one with the smallest exponent? X squared. So that's the one we use. They have 2 x's in common.
And that's it. Wait, can you do the.
Do they both have a y?
Yeah.
Okay, which one's the smallest exponent?
What?
So that's the one we use.
Oh, I don't know if you add them together.
Nope, you just leave them just like that. So basically, you can only use what they have in common. So kind of like here, do you see how 32 had 4 2's and 24 had 3 2's? We really took the one with the smallest amount of 2's, right? They took 3 of them. So basically, if I have 5 Snicker bars and Miss B has 2 Snicker bars, how many Snicker bars do we have in common? If I have 5, she has 2. How many do we have in common? 2. Okay, she doesn't have the 3 extra that I'm going to eat later. She only has 2. So that's a kind of way to look at it too. What do they both have? All right, moving right along. Thumbs up if you guys are kind of remembering this. And thumbs up if you got it. Thumbs in the middle if like you're getting there. Thumbs down if you're like, I don't know if I was here Friday or Monday.
I would say here Monday.
Okay.
So
how do I start finding the greatest common factor for these 3 terms? Factor tree. What's for 15, AJ?
5 and 3.
Okay, keep going. For 6
3 and 2.
and for 10.
5 and 2.
So I come over. All right, 15, 6, and 10. So 15 we said 3 times 5. 6 we said 2 times 3. And 10 we said 2 times 5. Do any of these numbers have a common factor? They all three have to have it in common. Do they all 3 have a number in common? No. When that happens, what's the greatest common factor? What number out there has what number is a factor for every single number out there? 1. So then we're going to look at our variables. Here we go. Do they all have a C in common? No. Do they all have a D in common? Nope. So what's my greatest common factor? Just 1. So they don't all share a variable. They don't all share a number other than 1. So here the greatest common factor is just 1. Okay, flip your opener over. On the back side is what we're going to be learning today. using the rectangular area model backwards. So we're adding one more piece into our puzzle to get us to factoring. I like this lesson, but I'm going to warn you guys, after this lesson, so what we learn when we come back from spring break, that's where it's going to start getting hard. So I like this lesson, but I will be honest, I feel like there is one more easy lesson, but it's mixed in. But it's like mixed in to more complicated lesson. So this is really, truly your last lesson where like you'll be okay if you're like, okay, I don't get it at the beginning. But the next few lessons, if you're not understanding, it's really important that you see one of us to get help, okay? Okay, so what I want you to look at here is the information that I've been given. I've been given a number here, missing numbers, an equal sign, and 2 numbers here. What do these, and then I've been given an area rectangle, an area model. So we need to determine what these numbers all represent. So when we're looking at our rectangular area model, what number goes out here? The number that represents my height. Then the numbers that go on top of my area model are the width. What number goes down here?
The height. I mean the width.
You're like,
Wait, what?
your number.
What? Say it again. The total area, right? Because we do height times width in the inside to get our total area, and we write our total area on the bottom. Now think about how we format our answers. The first part, when you have a number in parentheses, that's representing my what? My height and width. When I put my equals and I have a set of numbers like this without parentheses, that represents my area. Yeah. So we have some missing information that we need to find. What's the missing information we need to find? What don't I know?
What is times by?
The width. I don't know the width. So I'm going to label what I do know. So I know that this first number here is my height. I know that the second group of numbers should be my width, and that's what I've got to find. And I know this over here is the area of the rectangle. Okay, so my height is going to be 8x squared y to the third. I don't know my width, so I can't put that up there. But I do know the area of each section. What's the first area I have?
36.
Nah, 32.
32.
X to the second, y to the fifth. And what's my second total area? Negative 24. X to the fifth, y to the third. Okay, so I know my height and my area. I need to find my width. So what I'm going to do is I'm going to write in my height, like I would show my work in any other problem, times something, because I got to find my width here. And then I'm going to do it for this one too. My height times something to get my area. So I'm trying to figure out what that something is. I'm trying to figure out what that width is. So how I like to break it down and how I like to look at it. I'm going from 8 to 32. So 2 ways you can think of it. 8 times what will get me to 32? 4. So 8 times 4, 8 times 4 will get me to 32. If you don't know that, use your multiplication chart. Or you could just take 32 divided by 8 and get 4. Okay? Now, we're not done though, because now we have to worry about those variables and those exponents. And this is where sometimes people get a little frustrated or confused. So we're going to break it down. How many x's do I have for my height? How many x's do I have for my area? So do I need any more? Nah. So I don't have to worry about putting in any x's. So then I go to y. How many y's do I have in my height? How many do I have in my total area? How many more do I need then? So I'm going to have to put y to the second up here with my width. So what's the width of my first section? What's the width of my first section? There you go. So I'm going to label it accordingly. Biggest thing that you guys have to remember, show your work, label. Okay? So now I'm just going to repeat. So again, I'm going to think, 8 times what gets me to negative 24? Not just negative 3. Good. And if you didn't know that, you could take negative 24 divided by 8, and it'll give you negative 3. Okay, now I need to look at my variables. My height has 2 x's. My width has 5. Or excuse me, not my width. My total area has 5. So how many does my width have to have? Well, if I have 2 here and I have 5 here, how many more do I need? 3. Okay. My height has 3 y's. My total area has 3 y's. So does my width need any more y's? No. So what's the width of this second section? Okay. Almost done. What is the last thing, Cody? Dude, you got to stay with me. You're all right, but. So what's the last thing that you need to write in? What's the last thing that we're missing? Yeah, your answer. So what's my answer? 4y to the second is my first height. Or excuse me, my first width. Negative, so negative what? There we go. That's it. That's what we're doing today.